Good afternoon and good evening. Welcome to Inner Circle Vulnerability Management as Offensive Security. Today's session is being recorded and will be available for on-demand replay. At this time, I would like to introduce to you Johnny Shipp, X-Force Red VMS, Practice Lead in IBM. Over to you, Johnny.
Hi, everybody, and thanks, Nick. My name is Johnny Shipp. I'll be your host today. We're really excited to present on the topic of vulnerability management as offensive security. And I'd like to introduce to you two thought leaders, Steve Osepik and Fatih Bulut. Steve is the X-Force Red CTO and is also a distinguished engineer. He's had several patents that have led the vulnerability management industry, especially in reprioritizing vulnerabilities according to weaponized exploit and risk urgency. Dr. Fatih Bulut is a master inventor, technical lead at Hybrid Cloud Services at the Watson Research Center. His expertise in artificial intelligence and machine learning and cloud security are really bringing a game-changing aspect to vulnerability management as we know it today. So without further ado, I'd like to present to you Steve Osepik.
Thanks, Johnny. It's great to talk with all of you today. Really think this is an exciting topic because it's taking that we usually look at as more of a defensive measure, vulnerability management, and taking an offensive security look at it. And I think that you'll agree when you start looking at vulnerability management through this lens, you start to really think about it differently, as in, what are the attackers trying to do? What are the things that the attackers, how are they trying to get in? What are the vulnerabilities that are most interesting to the attackers? So we'll just go through the disclaimers here and then back to that. There we go. So some definitions just to get started. And some of this is quite basic, and many of you have probably seen these terms, heard these terms. Just going to lay some groundwork for the discussion today. Vulnerability, very basic. It's a very basic definition. It's something that allows unauthorized access. It could be something, a system that's out of date and it's patching. The vulnerability is that, that's what makes it vulnerable. The vulnerability is that there was a security flaw that has been fixed with a patch, right? Maybe that, and that can be caused from the application having insecure logic, some kind of flaw. A lot of times configuration can be problematic. It can be misconfigured. So that's a vulnerability. A CVE, common vulnerabilities and exposures. This is a system that is managed by a group called MITRE. And this is a code that MITRE gives as a reference, as an ID for every vulnerability that's out there from a vendor or open source software perspective. So you can think of this as a lookup number. But it for the purpose of our discussion today, think of CVEs as something that somebody else messed up, had a problem with, a vulnerability, not in the way of configuration. So for example, a default password, that's a configuration problem, not a CVE. That's up to the user to change the default password and make sure that an attacker can't get access to it, versus hard-coded credentials or a backdoor where it's a password that maybe a user is not aware of and they don't know to change that. That is a CVE because that's something that the vendor caused, where they caused the problem. CVSS is a common vulnerability scoring system. This is a metric, very, very common. It's across all vulnerabilities. Anytime you have something that has a CVE, you're going to be able to look up and see that it has a corresponding CVSS score. It really measures how bad something is. It doesn't do as good of a job of measuring how likely it is, but that's because it's made for the researcher to use this score to report it on day one. It's a great day one metric. We'll talk more about that. We're going to be throwing in the term resistance strength. These are controls, and this is actually taken from what's called the FAIR model. That these are things that make the system harder to break into, that make make it more difficult. Things that defend the asset, right, from attack. This gets into a world called CIS, which we'll talk about later, and also these implementation guides called STIGs. An exploit, you can think of that as using the instance of using a vulnerability to do those unauthorized actions that affect, and you hear this term a lot in security, the confidentiality, integrity, or availability of an asset. And the risk is the overarching concept of that happening. What is the likelihood of a threat actor using a vulnerability to exploit a system? Go ahead and go to the next slide, please, there. So what we're looking at, when we take an offensive security view of vulnerabilities, our goal really is to focus in on the vulnerabilities that attackers are most likely to pursue. And it's interesting that, so if you look back on how vulnerabilities are, how they come about, how they're born, right? There are two very different paths that a vulnerability can take when it's created. The top path there represents the more common and the less problematic from a risk perspective, that path. It's discovered by a security researcher. It might be discovered by somebody in the X-Force Red Team. It might be discovered, by anybody who's doing security research, using a product, maybe poking and prodding at it, maybe accidentally finds a vulnerability. When that happens, we in the X-Force Red side, and those of us who are security practitioners trying to make it a better situation in InfoSec, we're likely to use what's called the responsible disclosure process, which is essentially reporting it to the vendor, and that's where that calculator comes in. That's where the CVSS score comes in, utilizing that to come up with a number to represent how bad the vulnerability is, and then after we report that vulnerability to the vendor, they figure out a patch. We coordinate with them to disclose the details of the vulnerability, sometimes disclosing that. Sometimes, frankly, you'll see a lot of CVEs if you go to what's called the National Vulnerability Database, which is where all of these are stored, or X-Force Exchange, our own vulnerability database that X-Force maintains. You'll see each of those vulnerabilities there has a description of what might happen if you don't patch. And that can vary wildly. Sometimes you have vulnerabilities that tell you exactly how to exploit. Other times the vulnerabilities are privately disclosed in such a fashion where they don't really tell you how to exploit it. They just say this might be a problem. There are even vulnerabilities where they don't know for sure that it can result in what's called remote code execution or something very problematic, but they suspect that it does. And they're telling you, please just patch this just in case. The other path, very different, is when these things are discovered by threat actors, right? So if a threat actor essentially discovers this vulnerability and is using it to, is exploiting it in the field, right, in the wild, they're creating weapons from it. They're creating what are called exploit kits, which are things that folks that want to utilize, that want to do basically campaigns, malware campaigns, will utilize these exploit kits to actually run their operations. Maybe it's to create a botnet, or maybe it's to do a ransomware campaign, right? That's where that comes in. And of course, they're marketing that exploit kit, and then threat actors are buying the use of that, and then basically, utilizing that in their campaigns to break into things. That's the path from an attack perspective we're very, very, very interested in. As if we put on the hat of the attacker and we look at these vulnerabilities, we have on one hand, in that top path, we have vulnerabilities that maybe we're the first to write the exploit for. Maybe it's not even a real exploit. Maybe it turns out that the researcher thought it was exploitable, but it wasn't. Whereas on the bottom path, of course, that's where the threat actors are going, because that's where the money is. That's where the attackers are going. These are proven. These work. I don't have to worry about maybe taking down a system, or at least not very often. Making a lot of noise. These are the tried and true vulnerabilities, and that's where you see some of the fancy names, right? The shell shock and all of the 0-day kind of Spectre meltdown names, and you start seeing the emergency patch, and you very, very different risk profile. You don't have to. You can go from the top to the bottom. You can have a coordinated disclosure, and then have a researcher or a threat actor find out that actually a vulnerability was much worse than what they thought, or using a patch, reversing a patch and figuring out how to break in. So those are the two different profiles. And again, look, if we take an offensive security look, we're really focusing on that bottom path. If you go ahead and go to the next slide, Fatigue. So we're getting back to the CVSS score. Most of the time, understandably, because it is the de facto score, we're using CVSS to try to measure this. The CVSS, we're actually, as IBM, we're part of the CVSS team. We're on the board. Fatih actually personally is on the board, and we're working to take some of the things you'll hear about today and work those in as much as possible to the CVSS version 4 standard. We think CVSS is a great step. It's a great score, but it is utilized in the field incorrectly. The problem tends to be that it's being utilized as the true risk today of something being exploited, when really what it's best at is that day one vulnerability disclosure process. And that's what it was made for, when myself or somebody as a researcher submits something to a vendor and fills out the form. That's what it was made for. It was made for that communication. So we'll go through a couple spots where we needed to move the needle a bit. This is where X-Force has really been focusing on trying to create more scores. We're always advocates for using what's there and using standards that we can, but we realized, based on a few things, we had to use AI and machine learning to expand this a bit to give us a good scoring system in terms of what is available today, right? And in terms of what we should focus on today. So go ahead and go to the next slide, Fatih. We'll talk through that a little bit. So as I said, it's a day one measurement, and a good example of how things can get problematic is there are different aspects of the CVSS. When you fill it out and you're talking to the vendor about your vulnerability and you're proud of it, you've created the exploit and you're excited to share that exploit with the vendor. Of course, the vendor is very, very unenthusiastic about your discovery, but you yourself, as the researcher, are very excited to talk about this. One of the things that you get killed on as a researcher when you're trying to talk about how problematic a vulnerability is something called attack complexity. There's a subscore. There are a number of subscores, and you take the lower of those two scores. So exploitability is an 8.1, and impact is a 9.8. Your score is going to be 8.1. Exploitability tends to get a bit killed because it's when you figure out how to exploit something as a researcher, it's very tempting and oftentimes very legitimate to say that the attack complexity is high. It's hard to break in. As a researcher, we're very we're very likely to say it's a high attack complexity because that's what makes us exciting as security researchers. We're kind of throwing the flower on our face and saying, "Oh, it took me all day. It's very hard to do this." But the problem with that is the minute you do that, you lose a bunch of points off your score because you're saying, well, it's very hard to exploit. Not just anyone can exploit this. You have to be a ninja like me to exploit this thing. And you've lost a bunch of points off right there. The problem is we're not taking into account that things like Metasploit, ExploitDB, GitHub, there are weaponized exploits in the field that somebody with very little knowledge can download and utilize and not even understand how any of this works and get access to it. That's one of the core things that we needed to figure out how to manage. The next slide, Fatih. So this is just, I do a lot of this discussion with folks who have also used CVSS, and again, I'm not beating up on it, but these are just references to where in the standard it exists. And as you can tell, I'm used to doing academic conversations about this, where there are the CVSS, debates and how this is a huge area of discussion. So we'll go ahead and go to the next slide. That's just from the PDF of CVSS. There's another part of this, which is these temporal metrics. And the temporal metrics at first, there's actually things like exploit code maturity in there, which is very exciting. And there's something like remediation level. So what this is meant to do, you don't fill these in. If you're looking at your output from Qualys or Tenable or Rapid7, and you're looking at your output and you're looking at those CVSS scores to say critical, high, medium, low, you're probably not seeing the temporal metrics or the environmental metrics. But there's always this thought, well, if you went through and you filled those out, you could actually get a better score. And then to a certain degree, that's right. But here's the problem we see if we put on our attacker cap, right? The exploit code maturity, the maximum that you can get, let's say that we have a vulnerability for which there are really hundreds of exploits, and it is being heavily utilized by threat actors to break into systems and spread ransomware. But we're not, we would call that exploit code maturity. We would call that mature. The maximum that you can do with CVSS version 3 is multiply your score by 1. The killer is that once the vendor releases a patch, it can actually downgrade the score from by 5%. So if you go to the next slide, and that's just sort of the proof there within the CVSS standard. If you go to the next slide again, we can see that what the end result is that something like a common vulnerability you may have heard of, Eternal Blue, that is exploited continuously. If you were to put a system that is vulnerable to Eternal Blue on the internet, you would get it would get exploited within minutes. It's MS17010. It's very, very, very well-known vulnerability. If you do all the math, you end up with, it's an 8.1 CVSS by itself, and that would go down to a 7.7 with a temporal and environmental. So again, this was what you're going to see today is our work and our research and our ideas on how to actually take these scores, enrich them, not doing away with CVSS, but add a wrapper onto those, right? Because the official fix is always going to be present over time, and MS17010 was patched a long, long time ago. We still see clients that have this vulnerability in their systems, and it's kind of hidden because of a lower CVSS below something that's theoretical. The attack complexity is not going to reflect how much effort it takes to actually break in, because you have attackers that are very good, are just going to pull down the Metasploit or exploit DB code. We can't really, using CVSS itself, track popularity of exploits in the wild. It's not made for that. CVSS is doing its job as a day one measurement. It's up to us as security researchers to build out more things that help to measure the risk today and combine it with intelligence. CVSS is doing its job as day one. We're trying to make it, we're trying to wrap it to make it better. So that's where we're at. If you go to the next slide, there's a great quote, and we actually work quite closely with Craig Lawson at Gartner, and our team through X-Force Exchange provides a lot of information, a lot of data to him every year to do his vulnerability analysis, because we do so much work in the space. But this is a great quote from them. The vulnerability rating schemes that don't take into account what threat actors are leveraging in the wild can cause our organizations to address less risky issues first. That's really everything you see today is really coming down to giving our clients the order in which to attack and drive down vulnerabilities. That's all it is. And a lot of work, a lot of great research has gone into this. But again, the goal is very simple. If I'm working on vulnerabilities inside of my organization, what do I start with? Where do I start? And how do I take this concept that Gartner and Forrester and all of the, everybody's really putting out to say use intelligence to target the riskiest vulnerabilities? That's where we're going. So Fatih, if you want to get into the work that your team has done in research and the work we've done together to do that, that's great.
Sure. Thank you, Steve. I think this was a great introduction. So the question here is, given the CV and CVSS score, how do we bring additional information into the table? And with X-Force Threat and IBM Research, we are working together to bring additional features into the table. If I go over this briefly, each one of these, the first thing is the weaponized exploits. So this is accounts of exploits in various websites that Steve mentioned, like Metasploit, ExploitDB, and GitHub. crawling all these websites and trying to see if there exists an exploit for a certain vulnerability. The second one is opportune score, and this is a score of 0 or 1, capturing whether a CVE is actually requiring an exploit code. This is the measure how simple it is to exploit the vulnerability. So if it's 1, it's basically something where you have either a passwordless login or default password. So this is a way to identify those simple vulnerabilities from an attacker perspective, because those are the things that they would easily exploit. The third one is the utility score, and this is again a categorical measure. There is 3 category here, 0, 1, and 2, and this measures from again an attacker's perspective how useful it is. 0 means it's not useful. 1 means there is attack chaining capability. Maybe if this is exploited, then the next step would be allow the attacker to achieve its objective. The second would be actions on objective. So you have a SSH login to exploit the vulnerability. The other tool that we are bringing to the tables is the MITRE attack techniques. So for each given vulnerability, we are working to map each one of the vulnerability into the attack techniques that exist today in MITRE. So this is a way to see if there are actually threat actors that are exploiting these vulnerabilities using these attack techniques, and in a way to understand better if this is something your industry is more interested in, because some threat actors actually target specific industries. So this gives a better idea about what vulnerabilities should I really focus on with this additional enrichments that we are bringing to the table, in addition to the CVSS score. Really, the objective here is that if you look at the traditional categorization of the vulnerabilities today, the left, this figure shows this traditional CVSS-based approach and their categories. And as you can see, there are many critical, many CVEs that are tagged as critical severity. But what we would like to get into is, with these enrichments, into the a pyramid that you see on the right-hand side, where we actually divide that critical into more finer granular level severity levels to know which ones actually we need to focus on first. In a way to, if this is a fixed one that has, a CVSS score, maybe something, and then there is utility and opportune categories that also help us to identify which ones that we need to focus on first. The problem is that, if you look at from a volume perspective, if you look at the National Vulnerability Database today, there are around 140,000, and it's increasing day by day. And if you actually look at the yearly increase as well, it's, the rate of increase also outstanding. Given this, how do we bring these enrichments to the table is a question. Even though in X-Force Red in IBM, we have subject matter experts, practitioners who actually tag each vulnerability with the categories that utility, opportune, and all these enrichments entail into. The problem is that the volume is not scalable. So we need to come up a way to enable AI for this problem. And here we have a machine learning service that runs periodically to tag each one of these vulnerabilities into their respective enrichment categories for utility, opportune, and the MITRE attack techniques. So this is done through a supervised learning in machine learning, where we have an amount of data that our subject matter experts tagged that we use to train a model. And this model is improving day by day, because this is an ongoing process. Whenever we have new data, the model is updated, so we have better accuracy and better assessment for a vulnerability. Just to give you an idea how AI help here in this context, you see two example, two CVE left and right. And one of them is a CVSS score 8.1, and the other one 7.1. And as you see, the left one has a utility score of 2. So this is the one that actions on objective. So this is the eternal blue. And the other one is a utility score 0. If you look at the left-hand side, you also see some of the words that are highlighted here. In addition to the score that's provided by the AI, the category of the utility enrichment, we also, with the help of AI, explain why we selected this category for this particular CVE. And as you see, some of the words that are highlighted with red or pinkish color here, right on target, like SMB, V1, remote, execute arbitrary code. So these are the things that actually makes a CVE very attractive to the attackers. The other enrichment that we bring to the table is the MITRE ATT&CK techniques, and here we also utilize AI. The problem here is that even though we have the MITRE ATT&CK techniques and we have all the CVEs today, there is no association between them. If there is, it's a really less amount of data. So we cannot really build an AI model just using the CVE data and the MITRE ATT&CK association directly. So here we have an approach where we come up with, instead of doing a direct mapping from MITRE ATT&CK, from a CVE to the MITRE ATT&CK, what we do is we actually map CVE into the CW, common weakness enumeration. So these are an enumeration of the weakness type, like this is a SQL injection type and all this sort of different types. And these are limited in some way. So if we map the CVE into the CWE, then we can actually map CWEs into the MITRE ATT&CK techniques. So this is our approach, and there are a sheer amount of data in CVE to CWE mappings in National Vulnerability Database, in X-Force Exchange, the database that we are keeping in X-Force as well for vulnerabilities. So this is a way of we are solving this problem. To map every CVE into the MITRE ATT&CK technique, we first go into the CWE, and then we map that into the MITRE ATT&CK technique. Okay, so we talk about vulnerabilities itself, but usually there is also all these best practices that we need to follow when we harden our IT system and infrastructure or cloud infrastructure. And this is what we call as resistance strength, inspired by the FAIR risk framework. So these are the configuration issues that you need to follow. It's governed by technical specifications like CIS benchmarks, which is widely used in the industry, or Security Technical Implementation Guide from a US DoD. These are documents that are specific to each operating system, each application or middleware that specifies what needs to be done. And you see an example on the right-hand side for a Red Hat Enterprise Linux benchmark. This is basically saying that ensure that the FTP server is not installed. If you don't follow these best practices, then there is, in some sense, a vulnerability, an open issue that the attackers can attack and exploit. So in a way, it also possesses some risk. The question here is that how do we assess the risk here? And that's where the AI also comes into the picture. So given a vulnerability, we have an AI approach that are given a control issue CIS benchmark from a CIS benchmark. How do we assess the risk of it? And this is where the AI comes into the picture again. So we have a model that we built using a national vulnerability database. So this is from vulnerabilities. But then in addition to that, we utilize transfer learning. So we learn some of the things that we learn from the vulnerabilities and apply into the domain of the resistance strength onto the CIS benchmark and STIX documents to understand for each control what would be the risk if you don't actually follow this guidance. And this will give you a better idea, because then you would be able to better assess the risk in your system, not just looking the CVEs, but also looking into the issues that you as a best practice need to follow, but you didn't for some reason. So in a way to provide a better risk assessment capability. Not just that, we also apply AI to one more thing, and it is the vulnerabilities that don't have the CVSS score yet. So sometimes if you look at the NVD, you will also see, this is a manual process today, many vulnerabilities that doesn't have a CVSS score yet. So we apply AI. Given a description of a vulnerability, we would be able to actually generate the CVSS score from a vulnerability. And also this could be used for many other purposes as well. So if you have a small description of what the vulnerability is and what the risk is, you can feed this text into the AI model, and the AI model that we built would be able to provide you a CVSS score to start with. And lastly, how all this information that we talk about, comes together. And this is what this chart is about. I think you would be able to access the charts, but very briefly, if you look at the bottom here, you see on the left-hand side the baselines that we built. So for a vulnerability management perspective, there are CVEs, and for CVEs, there's usually a CVSS score. So that's like the baseline. And then also the utility, opportune, and MITRE ATT&CK techniques, all this comes into together as an enrichment to the CVE. And then from a resistance strength perspective, then there is this, all the CIS benchmarks or stick documents and controls within those. And for each one of these, you have a risk that we built using our AI model as a baseline. And then, you have a resource baseline. These are the environmental factors that you need to take into the account, because when we talk about risk, we also need to talk about all the details of the environment. For example, if your server is public facing versus private facing, this makes a lot of difference in terms of risk quantification. And lastly, the criticality. Whether this is, your crown jewel, it's very highly critical versus it's a non-critical system. So this all affects, which one that you need to focus on the top. And on the right-hand side, what you see is basically the operational results. So using the scanning tools for the missing CVEs or scanning tools to understand what are the configuration issues from a resistance strength perspective, and also using an inventory to understand the resource characteristics. So one example is whether your resource is public facing or private facing. And on top, you see a simple formula. This doesn't need to be a single right formula that you need to use, but at the same time, it gives you an idea and starting point, and you can customize this based on your needs. But basically, it combines the CVSS score, the environmental factors, the weaponized exploit that we talk, utility, opportune, and criticality. And this is done through both to the vulnerability and to the resistance strength in a way that allows you to combine both of these together for a given asset. And then you can also aggregate this risk into a group if you have different groups in your system, like dev, production, or some other groups that you can come up. So you can also evaluate risk for a group, and then you can also come up with an account risk if what would be the account risk. So at different levels, different personas may be interested in the risk, and in a way to understand the risk posture of your IT environment.
Mm-hmm. And I would just add here, we looked at this, and I didn't know there's a lot going on the chart. As Fatih mentioned, you do have direct access to the chart after the presentation. Being that this is the inner circle, we wanted to just put everything on there. There's a lot going on, and it doesn't mean you have to obviously implement all of these things. Some of these things you might not even have in your environment, but it gives you more of think of it like a roadmap when you're figuring out how you want to implement something that goes beyond what CVSS gives you from that perspective. And of course, we'd love to work with you from the X-Force side, but your own organization, these are some things you can think about and ways you can look at it. The difference between this effort and, oftentimes the question comes up, how is this different than FAIR? FAIR is very, very valuable. FAIR, and actually, if you just want to go to that next slide, Fatih, yeah. I can start here and you can jump in. But this really shows, think about what we're doing here as being the daily operational, the cadence being very rapid, very, very quick turnaround. FAIR is a much larger, usually biannual, much broader engagement that is performed by auditors, which is extremely valuable. Imagine what we're doing here with this box sort of feeding into a FAIR assessment that's done quarterly or biannually. But also can be utilized. This is all trying to use AI and formulas to rapidly come up with these solutions. And again, getting everything into that point where you know on a daily basis what are the vulnerabilities should be working on. So did I say that right, Fatih? I just wanted
Yeah,
to
you
add that
you
perspective because every time
you
I look at
put
that
it
slide, I
perfectly.
get by. But it's going to be great, I think, for the group to come back to later.
Yeah, you put it perfectly. Johnny?
All right. So how does all this help? Being in operation, I'm sure I'll not be the first to tell you, but identifying problematic CVEs that have no exploits is like finding a needle in the haystack. So this chart represents the evolution of CVE history along with the rise of weaponized exploits and 0 days. But if you really take a step back and you look at it, it's really one big haystack of 153,000 plus vulnerabilities. And those popular vulnerabilities that you see here on the screen are those needles in the haystack you know about. But how about those needles in the haystack that you don't know about? And that's where opportune and utility and machine learning shift the ranking paradigm as we know it today. So through opportunity, we can identify those vulnerabilities that can be exploited without an exploit. Through utility, we can identify those really urgent vulnerabilities that are juicy in the eyes of a threat actor. And with machine learning, we can further predict and identify those unknown needles in the haystack, the downstream remediation team, before threat actors can capitalize on what is unknown. So in using the risk-based calculation Fatih was discussing earlier, we can further prioritize vulnerabilities not only based on exploitation indicators, but also based on network topology, business criticality, sensitive data, and other control elements. Next slide, please. If you can finish the transition as well. Fatih. Thanks. So let's talk about a use case. So this use case was conducted over 8 clients across both the financial and industrial sectors. On the left, as Fatih was talking about earlier, it's the traditional model of vulnerability data categorized according to severity. Notice I said the word categorized and not prioritized. So without having the ability to prioritize vulnerabilities with some degree of weaponization scoring, it's like taking a category of data, a chunk of data, and throwing it over the proverbial wall for downstream remediation teams to fix without any sequence, any sort of prioritization. So maybe some vulnerabilities might get fixed, but you cannot maximize the potential that the really urgent vulnerabilities will get assigned and then fixed. So now when we look to the right of the risk prioritization pyramid, we can immediately identify, or in other words, extract 15% of the known and the unknown needles from that client CVE haystack, whether they have weaponized exploit, opportune, or utility score. So then we can further drill up in the model into 10% of the urgent vulnerabilities by combining weaponized exploit with either opportune or the utility scores. And we can even take it further into a next level of risk urgency, or you better fix it now, where we look at those really, really nasty vulnerabilities that have the weaponized exploit score, an opportune, and a utility score. So if we can move to the next slide, Fatih. And hit the space bar. Yep. So our risk calculation provides us here with both the capability and flexibility to customize the risk scoring according to what's known about the client's environment. Is it mission critical? Is it externally facing? So we can further amplify the precision in prioritizing not only vulnerabilities, but which assets to target first. And I cannot begin to express how vital the need is for clients to have an asset management program, strict governance to where you can identify not only the owners of the device, who's the operating system application database, but also if the device is used for a mission critical function. So kind of winding down the presentation here, we talked about some of the inherent challenges with using the CVSS score only to determine risk. We talked about the advantages of using weaponization, machine learning to prioritize the really urgent vulnerabilities of those known and unknown needles in that client CVE haystack. So with that said, we're really excited to provide this technology to our clients. And I think Steve and Sati, are you guys ready for questions? I know I am here.
Yeah. No, that's great. And I just on this slide, real quick, something to if you could just go back there real quick, Viti, I'm just going to talk to that visual, which I really love, the pyramid that Johnny uses. Imagine that, and the one point that that really modifying the way in a lot of cases that organizations, by using this type of approach, look at vulnerabilities, not just from the criticality piece, but from that concept that there's always going to be something that is the most important thing to fix, right? There's always going to be the most important. Like I said at the beginning, the goal of this is to get your organization to the point where you have folks who are within the security operations or within the system, system administrators or what have you, system owners, who are able to fix things. Tell me what is the most important thing to fix. And frankly, there will always be the most important thing to fix. What we run into is a mentality where a lot of clients say, well, I'm going to focus on the critical and the high, which is over half of the vulnerabilities. And even if they just take the critical, they find themselves very behind. The backlog is unmanageable. So in doing this, we've also been working with firms to get this into an audited fashion. I come from a background, a financial services background, where I've actually spoken directly with the FFIEC myself in turning around programs. And I know that auditors want to see a repeatable process, an achievable process. They don't like it when CISOs go into those situations and say, I'm going to go back and I'm going to crack the whip. We're going to take care of this, right? They want to see something achievable, repeatable, and something that they could imagine working. And this concept of changing the way that we look at vulnerabilities and always focusing, always, even if you do get rid of all the high-end critical, you'd be the first we ever met to do that. But if you have a small environment, it's possible. Even if you do, there's going to be the mediums, there's going to be the lows, fine. But figuring out, based on all these characteristics, what is the most important one to work on? What are the most important ones to work on this sprint, and starting to tackle it the way that developers tackle backlogs in a much more sane fashion in terms of what is the most important thing to work on. So that's a very big shift, right? And it's subtle, and I think we sort of gloss over it, but it's a big shift between the fix all the criticals, fix all the highs, and punish people for not doing that. That's most of the time when we're working with clients. That's the core thing that we're trying to get across. So yes, very much looking forward to taking your questions if you have any here.
I have our first
this.
question, Steve. So what's the first thing to do to set up a model like this for a client that's already running their vulnerability management program?
question. We've been talking the whole time about it. Now this person's asking, where do I start to do this? I think that Johnny and and Fatigue, keep me honest, but I think what we tend to do is take the whole point of this presentation. We're talking about attacker minded, looking at the vulnerabilities themselves through the eyes of an attacker. That's usually easiest, just in terms of logistics. The easiest thing is usually to take those vulnerabilities, the output from Qualys, Tenable, Rapid7, Nessus, VAST, whatever you have, and correlate those CVEs with the weaponized exploits utility opportunity, get that score, right? Because now what Johnny said is very, very important about the assets being because what it'll do, usually when you do that, and you start to do things in actual threat order, you'll show up with an MS-17010, Shadow Brokers, Eternal Blue, Shell Shock. All of a sudden you'll get some things at the top, and you'll say to your team, I thought we already took care of that, and you did. But you didn't realize it's because it's not going to have CVSS, a massive score when it comes to exploitability. So those will be the first eye-catching things, and usually the way it works is you see that you do the ranking that way, and then you start to see those vulnerabilities, like you see the blind spots because you're shocked that it still exists in the environment. That causes you to start to dig into assets. So start with the vulnerabilities. That's what I would say. Start with the vulnerabilities. Yeah. Find those bad ones using the things we've talked about today. And of course, we'd love to work with you, but there's enough in the slide deck that you could do some of it, right? That's the point. We want to teach, not just sell you on this. And then start to look at the assets after that and figuring out your inventory. And I would say, Johnny, one of the things, and resistance, right? And the configuration flaws, as much as you can look at those from the things Fatih talked about, and then getting into figuring out where the assets are, the criticality of them. I think that's roughly the order. Johnny or Fatih, feel free to add.
Yeah, I think you're right. For me, it's the old ancient Sun Tzu, know your battleground. What is the battleground? The battleground is asset inventory. So being able to figure out and separate, which remediation team does what. So once you do get to the point of being able to prioritize according to, weaponized exploit, et cetera, you can immediately give those downstream remediation teams a set of really urgent tasks to work on. But what's also interesting about this work, it has other applications to where maybe a client has a lot of end-of-life assets, and they're trying to figure out from their point of view, what is the most critical thing to take through a life cycle upgrade. So we've had client projects in which we've helped clients determine, well, out of all of our end-of-life platforms, what should we fix first? And we've used weaponized exploit to fix that as well. Another application that is really, really interesting too is companies that have, a mature exclusion management program in which they have all these excluded records for whatever reason, false positive, mitigated risk, accepted risk. But how do you figure out which one should be renewed first? And so you can also apply this sort of intelligence and rank renewal records based on the most critical, which ones have the most weaponized exposure, etc. And so for me, it's always with asset inventory, get really organized, and then go after the risk ranking. Another question that we just received, how does this fit with OT, operational technology, versus informational technology? And so what I'd like to say about that is, Do you want to take that, Steve?
Oh, I'd like, go ahead and I'll jump in. No, that's great.
Okay. So what I'd like to say about that, the same premise applies. Yes, passive scanning versus, the traditional scanning, but it's still possible to, CVEs apply to OT and IoT as well. And there's always going to be those vulnerabilities in the field that have been reported from, offensive penetration testers. And that's where opportunity and utility really shine. What are those vulnerabilities that can be exploited without an exploit? From an attacker's perspective, utility, is this like really, really interesting? Is it not so interesting, or is it somewhat interesting to where you can attack chain? But what's interesting about utility where it's not interesting at all, that's a big time saver, right? Because I want to know what's really, really juicy and what's not interesting at all, because that's probably the last thing that I'm going to recommend for people to fix, as opposed to vulnerabilities that are receiving, a lot of attention, in hacker repositories and frameworks and et cetera. So let's see if there's any more questions. Go ahead.
I would agree with that, Johnny. I'm just going to say another couple words on it. The remediation is the tough point. Utility really helps to understand whether it's relevant. As you know, there's a whole discussion on OT in terms of what can be fixed. There are many, many OT devices in our clients' networks that are working perfectly fine, but have vulnerabilities in their end of life, their firmware's end of life. So we really, in those situations, we work with clients, and you can do the same thing to really look at what's attack surface. It comes down to attack surface mapping. Is there an air-gapped environment? Is it truly air-gapped? Is there a way to talk to those devices? All of those things. A lot more on the remediation side comes down to segmentation and actually just detection of those attacks. And I apologize, I had to turn my video off. It was getting a little choppy. But essentially, looking at it through that lens, there's a great, well, I shouldn't call it great. I'm on it. At least half of it's great with my buddy Marty from Tenable. We did a talk elsewhere at Think that you can look up, where we talk about the OT landscape and how to do vulnerability management in the face of OT. And it's a shared segment between Marty Edwards and myself, and he's from Tenable. So I encourage you, if you're interested in vulnerability management and OT, a little shameless plug there for that talk elsewhere at Think.
Yeah, and also we very briefly, we also talk about the environmental factors, and that's where some of these things fit into as well, where we talk about end of life, we talk about public facing, private facing. So this is a way of plugging this information into the risk formula to, get attention to those issues and very quickly, find the ones that really needs to, we really need to pay attention to.
Okay, we got another question in. Can this methodology be applied to application and container scanning?
Yeah, I can take a shot at that. Absolutely. We actually do similar from the container side. The vulnerabilities that we pick up and rank are going to be from tools like Aqua, Prisma, Claire, which is the Red Hat tool. If you look at those scanners, it's a very similar scenario where it essentially what those are doing is looking a lot of times at the registry, the images themselves, that looks at the base images and figures out whether or not those vulnerabilities, what vulnerabilities exist in some of those base images. It usually comes down to looking at it through the lens of like the frameworks and the libraries. And the other thing you really have to keep in mind in container is that not all of those vulnerabilities are actually going to have attack surface. It's sort of back to the same concept with OT. If you have a low-level Unix command like curl that is vulnerable to something like a man-in-the-middle attack, but curl's never being used because these containers are never being used interactively like that. They're being used for their services. Some of those vulnerabilities in base images really don't matter. The ones that matter are the ones that actually influence the middleware, the Apache, Tomcat, whatever's being utilized in the middle there. Those are the ones that we tend to focus in on more. Application is a similar situation, but application scanning, DAST and SAST tend to produce a smaller amount, if done correctly, a smaller amount of vulnerabilities that are going to be very specific to that application. And for that, X-Force Red, from an offensive security perspective, we review that just directly through the eyes of an attacker being, we offer that as a service, and we look at it from the perspective of an application developer. And what does this mean to us, right? It's a little less mappable, if you will, to CVEs at the application level, because a lot of that tends to be application logic. But with that being said, the technology that we talked about today that FATI and the research organization has produced in terms of natural language processing, that allows us to do ranking of things that really don't have a CVE or anything of that nature. So that we're looking at applying to all of those use cases as well, where CVEs just really don't make any sense, and we just have the description.
Yeah, I totally agree. And I just want to add also, another use case where the shift left scenario, where there are, scanners where you analyze your code in GitHub or Git, and then, all these vulnerabilities and configuration issues are pop up. So it's a little bit different concept than what we have been doing traditionally with the servers and scanners, but still the same applies to shift left as well, where you analyze your repositories that might belong to an application or multiple application. You ended up finding all these vulnerabilities that some of these belongs to the containers in a Docker file that you use in the repository. Some of them might belong to the source code itself by the static and dynamic scanners. And using those, we would be able to, again, analyze and apply to the same methodology that we talk about today and analyze the risk. Definitely, it applies to all of these scenarios.
Yeah, containers is very interesting, isn't it? It's several different attack surfaces of the registry, of the host, and also the running containers. And it really spreads out the landscape to apply these techniques to. I don't see any more questions coming in. So if you have any last questions, please type them in. I can come up with a question. What's a good way to determine asset criticality? So we don't have a very mature asset management system, but how do we get started? And so what we've done in the past is so X-Force Red VMS, what we've done in the past to help clients that don't have that started, we work with them, and we have these interviews through run books to go through pretty much the whole entire asset inventory of teams, those remediation teams, who builds them, who supports them, and what is this for, right? So that's how we've done it in the past. I mean, there's probably other sophisticated ways, probably machine learning can be thrown in there eventually, but it's the process of building it. And your asset inventory is as good as the people or the automated processes inputting the record. So,
and you'd say, Johnny,
well, we have two whole things.
The scan data to actually feed that process, I think, is
right.
what I've really seen really be, because you can't just rely on a manually gathered inventory. It's using that scan data. Anyway, did you say there's more questions there?
Yeah, we only have one more minute, but
okay, sure, we can try it.
Anyway, yeah. So Does anybody have any more questions? I think we can pretty much wrap up, but I wanted to thank the audience for watching and Steve and Fatih for their thought leadership to making the magic happen. So thank you very much.
All right. Thank you, everyone. And we're always glad to talk more with you offline.
Thank you.
Afterwards, please look us up if you'd like to work with us. We'd love to work with you. Thanks a lot.
Thank you very much.